Hello. Okay, test 3, which question?
24.
Okay, you mean this question?
Yes.
All right. Okay.
I found A divided by B, but I didn't find A times B.
All right. Let me just copy this immediately to our. Okay. Okay. Now you can see, right? This question, right?
Yes.
Okay. Okay, can I see your face? Why are you hiding your face, or your interconnection is not
Okay.
good? Helium, why did you change your name?
No, because we had in school, once we used Zoom, and because this I changed it.
Okay. All right. So here, the first Ibrahim, right? Your name is
What?
Ibrahim, right?
No.
What's your name?
Arad.
Arad. Arad. Your name is Arad. Ibrahim in another class. Okay, Arad. Arad. Here, first, as you see here, A and B, these numbers are integers, right? You know what is integers? Maybe that is like
Zero,
negative
I
3
mean
or
negative
negative
3,
2 or negative 1 or 0 or 1, 2, these numbers. Okay. So that is given. So we need to find A times B. All right. Okay. From here, I can just write it as 15 to the power of A plus B. Take this 3 to the power of A minus B to the right-hand side. So here we have 9 times 3 to the power of A minus B, right? And from here, also this 15, I can write it as 3 to the power of A plus B times 5 to the power of A plus B. On the right-hand side, we have 3 squared times 3 to the power of A minus B, right? Or I can just divide both sides by this, 3 to the power of A plus B. Then here we have A and 5 to the power of A plus B is equal to, here we have 3 to the power of 2 plus A minus B. And we are just taking it to the right-hand side. So here we have minus A minus B, right? Because here we have 3 to the power of A minus B over 3 to the power of A plus B. So now if you simplify this, 5 to the power of A plus B is equal to 3 to the power of 2. This A cancels each other. What do we have here? Minus 2B. Okay, so here, this condition is important, Arats. A and B are integers. So here we have 5, which is a prime number, and 3 also is a prime number. And 5 to the power of integer and 3 to the power of integer. When they are equal to each other, we have only one case. Only actually it is true if A plus B is equal to 0 and 2 minus 2B is equal to 0. Otherwise, they are never equal to 0 because powers of 5 is always, what is it? Like 5, maybe 25 or 125, right? And how about powers of 3? It is 9 or 27, right? They're never equal to each other. Only the case because 5 is prime number, 3 is prime number. So when A plus B equals 0 and 2 minus 2B equals 0, at the time, here we will have 5 to the power 0 will be equal to 3 to the power of 0. So if you solve this from here, B is equal to 1. If B is equal to 1, then A should be equal to negative 1. So what is the question? A times B, which is equal to negative 1. Okay.
Yes.
Maybe if this one is not given, all right, if A and B are not integers, at that time you may think differently. But because it is integer. That's why integer power of 5, these are all multiples of 5, right? And how
Yes.
about multiples of 3? I mean, not multiples, powers of 5. And powers of 5 is never equal to powers of 3. Only is equal to if the power is equal to 0. Okay?
Okay.
Any other question from that paper?
No. Just there's no problem if I didn't meet logarithm.
Yeah, actually, you should solve those questions without using logarithm. Okay?
Okay.
Good. So, Aradna, we will continue today. We will say a few different questions about this indices and surds, and I will finish this chapter. If we have time, we will talk about linear inequalities today. Okay?
Okay.
Arad, you hear me well, right?
Yes.
Okay. Actually, you solved a lot of questions. If you can solve those questions, it's good, it's great. But still, you know, as you solve more different questions, actually, how to say, you have better and better experience. So indices, we talk about this. We just have some different questions and we will solve them quickly. And after that's enough for this. Example 2 here, again, simplify each of the following. To simplify this, what should we do here, Arad? We have to
Make it
change
the
these surds into fractional indices, right?
yes.
So here the first one is a to the power of 1 over 3 is divided by a to the power of 2 over 5 times a to the power of 1 minus 1 over 2. Then we should just simplify. Here we have a to the power of 1 over 3. It is divided, so it is minus 2 over 5. And multiplied, it is plus, but because of this minus 1 over 2. And we can just simplify this. What is it? The common denominator is 30, right? Here we have 10 minus multiplied by 6, it is 12, minus multiplied by 15, that is equal to a to the power of minus 2, minus 17, minus 17 over 30, or 30th root of a to the power of minus 70. Whichever, actually. I didn't ask anything, so we can just live in this way. How about question B? Sorry. Question B also, simplify. How can I simplify this? Here we have 12, here we have 6, here we have 8, right? So actually we need to write the bases, right? The 12 is a base, 6 is a base, 8 is a base. So we should first write the bases as a product of prime numbers. After that, we can reorganize and simplify this. So we know that this 12 is, I can write it as 2 squared times 3 to the power of 2x plus 3 times, how about 6? It is 2 times 3 to the power of x minus 5. And 8, it is 2 cubed to the power of 2x minus 1. So after that, here we have, let me just write 2's first, 2 to the power of 2 times 2x plus 3, that is 4x plus 6. Let me just do this directly. In the second one, here we have 2 to the power of x minus 5, so here we have plus x minus 5. In the third one, we have 3 times 2x minus 1, so that is plus 6x minus 3. Okay, with base 2, we are done. How about 3? See, here we have 3 to the power of the first one, 2x plus 3, 2x plus 3. The second one, plus x minus 5. And that's all. Equals, if you simplify the first one, 4x plus x, 5x plus 6x, that's 11x. 6 minus 5, 1. 1 minus 3, it is minus 2. Times 3 to the power of 2x plus x. It is 3x, 3 plus 5, it is 8. Right? As you do more questions, a lot of steps, you can just do this mentally and you can get the answer much quickly, faster. How about C? How do you solve C?
Make it to the powers, like to prime powers, then divide. It's mean like cross.
Okay. All right. So the 81 is 3 to the power of 4. So that is 4x plus 4, right? Minus, here 9 is 3 squared. So it is squared 2 times 2x. It is 4x 4x plus 2 times 1. It is 2. Over, here we have 3 to the power of x minus 4 times 3 to the power of, what is it? 27 is 3 cubed, right? 3x plus 6. 3x plus 6. So from here in the numerator, what is the common factor?
Common
Okay, first let me
factor.
just simplify the 3 to the power 4x plus 4 is a common factor, right? Or maybe plus 2 for x plus 2. So here we have 3 squared is left, minus 1 over. And if you simplify these two things, what we have here, 3 to the power of 4x plus 2. So here we have 3 to the power of 4x plus 2, right? So these two things, they're gone, common factor, and 3 squared is 9, 9 minus 1 is 8. Okay?
Okay.
I mean, Arats, here, I'm not showing you how to do these things, okay? Here, I'm showing you how to do fast and do some calculations mentally, all right?
Okay.
Another example, it says that if y equals to x, but it's given actually a hint. Even it's not given, you have to think like this. Introduce some new variable, okay, and after the substitute and simplify this. Express each of the following in terms of y. So in A, so since y is equal to 2 to the power of x, I can write it as 4 times 2 to the power of x minus 1 over 2 times 2 to the power of x. So here we have, what is it? 4 to the power of x, half to the power of x. What do we have here? Here we have 3.5. It is 7 over 2 times 2 to the power of x, which is equal to 7 over 2 times y. So we have expressed the given expression in terms of y, where y is equal to 2 to the power of x. How about in question B? All right, why we are doing this? This actually method is very useful to solve exponential equations. Sometimes if exponential equations are very complicated, so we have to introduce variable like this and interchange this with this variable, solve it, and after that we can find the value of x. How about in the second one? I can write it as 2 times 2 to the power of x plus, and here we have 4 to the power of minus 1, which is equal to 1 over 4 times 2 to the power of x, right? Minus, how about here, 8 squared, that is 64, times 2 to the power of 3x. Now I can substitute here 2 times 2 to the power of x is y. So here we have y plus, here we have 1 over 4. 2 to the power of x, we know that we can write it as 2 to the power of x squared, which is y squared minus 64. 2 to the power of 3x is, what is it? Y cubed, right? So we have expressed the given expression in terms of y. Okay, and also solving exponential equations. Last time we talked about this. I just solved only B parts. I think you can do other questions. What is 4 to the power of x plus 1, right? 0.25 is, I can write it 1 over 4, which is equal to 4 to the power of minus 1. So from here, what is x? X is equal to negative 2. Okay, this is just very simple. Let's solve another question. Solve the equation by using the substitution of y. Even out this part is not given, we should be able to solve using this method, right? Introducing new variable. So here, if y is equal to 2 to the power of x, 2 to the power of x, then what we have here? Here in the first part is I have 2 cubed times 2 to the power of x, and here we have squared plus, here we have 2 cubed times 2 to the power of x. On the right hand side, we have 1 plus 2 to the power of x. Now using this, notation, if you right here we have 8 times y squared plus 8 times y is equal to 1 plus y. And
Then
it
we
just
can write
becomes a quadratic equation here, right? So here we have 8y squared plus 7y minus 1 is equal to 0. So to solve this exponential equation, now we have to solve this quadratic equation. So can we just solve this by factorization? I think so. This one is 8y times y, and this one is negative 1
negative.
times 1. If you cross multiply 8y minus y is equal to this. So we can factorize it as 8y minus 1, and the y plus 1 is equal to 0. From here, y is equal to 1 over 8, or y is equal to negative 1. What is y? Y is 2 to the power of x. 1 over 8 is 2 to the power of negative 3, or 2 to the power of x equals negative 1. And we know that 2 to the power of something is always positive. It cannot be negative. So this answer is rejected, right? And here we have the answer. So it has one solution. What is the solution? It is negative 3. So the solution of this equation is negative 3. Only one solution.
In this example, we should find x, or we should find answer for the equation.
Yeah, we should find x. This is the equation, right? What is unknown here? X.
Okay.
Okay, we are just using this, this method, we are making this technique to solve the equation. And without this also we can solve this, but using this new variable, we call this introducing auxiliary variable. Our what is it? Solution is much faster and easier. Okay.
Okay.
Arat, can you solve this question? Can you write on the screen?
Given that, sorry, given that y is equal to ax to the power of b minus 5, and that y equals 7 when x, and when x equals 2, and y equals 22 when x equals 3. Fine. It means when y is 7, x is 2. I answer. Given that the y is equal to.
Arat, can you
In
write on the screen?
yes, which we should find a or b.
So you need to find value of A and B.
Okay, and on
Arat, you have 2 minutes.
it.
Okay, after 2 minutes we will discuss.
So can it be 3, because writing with this one is so hard?
Hmm?
Can I do it on paper than do on that? Because it's much easier.
Can you what?
Can I first do on paper than write on this one? Because this one is so it will take.
Okay, Arat, now tell me, I will write. Okay, just tell me what to write here.
Is 7 is equal to a 2 to the power of b minus 5. Then minus 5 goes to there, it becomes 12. 12 is equal to 2. Oh, b.
Okay. And so we substitute the second one right now.
Yes.
So this
So
22.
it's equal to 27 equals a times 2, 3. Oh, yes. And 2 goes there, it become, no, it should be 5, not 2.
5?
Yes, this one.
Why
Because
5?
it's
Oh, 5, 5. Okay.
one second, I erase it.
Okay. 5. So it is 27.
Yes.
Okay, now we have two equations. What is next?
Next, we should do we should find a in terms of.
Okay. We should divide, right? Because here a times something, a times something. Let's divide the second equation by the first equation. So here we have a times 3 to the power of b over a times 2 to the power of b. So here we have 27 over 12, right? So they cancel each other, and b is a common exponent. So I can write it as 3 over 2 to the power of b. And if you simplify this by 3, it is 9. By 3, it is 4. So we can write it as 3 over 2 squared. So
B
from
is equal
here,
to-
what is b? B equals 2,
yes.
right? So now if we substitute either in the first equation or the second equation, we will get the value of a. Let's substitute in the first equation. So this is step 3. Step 4, a times 2 to the power of 2, that's equal to 12. So what is a? A equals 3. So it is dot, 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 a equals 3, and b equals 2. Very good. Okay. Also similar questions, solve these simultaneous equations. Simultaneous, here also we have exponential equations, right? Using the same method, we can do this. Here in the first question, here we have 3 to the power of x, and here 9, I can write as 3 squared. So 3 to the power of 4y is equal to 3 cubed. The second equation, 2 to the power of x times 2 to the power of negative 2y is equal to 2 cubed. So we have simultaneous equations here. And the first one, bases are the same. So here we have x plus 4y is equal to 3. The second one, x minus 2y is equal to 3. Negative 3, right? Negative 3.
Yes.
And actually these two equations are, we call them equivalent equations, right? Equivalent equations means they have the same solutions. Equivalent equations. That means that they have the same solutions. And they are just simultaneous linear equations. If you multiply the second one by 2, right? Multiply by 2 and add them together. Here we have 2x plus x. It is 3x. Negative 4y plus 4y is equal to 0. Negative 6 plus 3, negative 3. So what is x? X equals negative 1. If you substitute in the first one, maybe here we have 4y equals 3 minus x, that is negative 1. So from here, what is y? Is equal to 1. So dot, 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 the solution is x equals negative 1 and y is equal to 1. Okay?
Okay.
Good. Surds, also we already talk about this. Simplifying. That is the last question, I think. Yes. This is one word here, Arat, that you should actually know here. Maybe you know this, rationalizing the denominator. Okay, that's also one important concept in math, because a lot of times when we're solving equations, we have to rationalize its denominator, then solve it. To do this one, for example, rationalize means how can I change its denominator into rational number? No surd, right? So we should multiply the first one by negative 3 over negative 3. So we call this, it is conjugate. So that is, what is it? 6 times negative 3. Negative 3 times negative 3 is 3. So that's equal to 2 times negative 3. And how about B? And it is conjugate. We call this conjugate surds, right? Conjugates. So here we need to multiply by its conjugate, that is square root of 3 minus 1. And here we have square root of 3 plus 1 times square root of 3 minus 1, which is equal to 3 minus 1. That's equal to 2 times square root of 3 minus 1. And how about C? Also, we should multiply by its conjugate. So here we have 4 times square root of 3 plus square root of 2. And here we have 3 square root of 3 plus 2 times square root of 2. And in the denominator, I don't have to write this because this one, right, and it's conjugate. So here we have 3 square root of 3 squared minus 2 square root of 2 squared. So quickly, if you simplify the numerator, 4 times 3, it is 12. 12 times 3, that is 36. 4 times 2, it is 8 plus 8. square root of 3 times square root of 2, that is square root of 6. And square root of 2 times 3 times square root of 3, that is 3 square root of 6. And square root of 2 times square root of 2, that is 2 times 2, that is 4. In the denominator, here we have 9 times 3, that is 27, minus 4 times 2, that is 8. So now if we simplify this, 36 plus 4, it is 40. And 8 plus 3, it is 11. Square root of 6 over 27 minus 8, that is 9. So as I see here, denominator is 9. We have rationalized the denominator of this fraction.
In the last one, why didn't you multiply it by 3 root of 3 plus 2 root of 2?
Now I multiply by this here, 3 square root of 3 plus 2 square root of 2. You see, this one is a minus b, is conjugate is a plus b, right?
But why it became squared?
So if you multiply, this one is a minus b, a plus b, that's equal to a squared minus b squared, right?
Just 1 second, I'm confused.
Okay.
Okay.
Okay. Arad, I have one question for you before we finish this. Now the same question, okay. Can you rationalize the denominator of this fraction? 1 over 1 plus square root of 2 plus square root of 3. You can do on that paper. I give you 4 minutes. Okay.
It shouldn't be 1, right? Both sides by 1 minus root of 2 minus 3.
Okay, do it on the paper. Take a picture and show me. You have 4 minutes. If you're ready, we can start. Okay, 4 minutes. So, it's not a so easy question. It's a little bit challenging question.
I found it.
Are you sure?
Yes. And no, actually, 1 second. Yes, I'm sure.
What is it?
It's 1 plus the denominator is 6. Nominator is 3 root of 2 plus. Can I write?
Tell me the numerator. Tell me the numerator. I'll write here.
Denominator is 6.
Denominator is 6. That's wrong. Okay. Numerator?
6 plus 3 root of 2 plus 2 root of 3. Actually, that 6 should be the same as denominator.
Like this?
1 second, I annulate 1 second. Denominator is 6.
Yeah, denominator is 6.
Yes.
Like this?
Yes.
That is wrong.
Actually,
how did you do it?
Why as well? Actually, I break the fraction. We get the fraction 1 plus 1 over root of 2 plus 1 over root of 3.
Okay.
Actually,
okay. Can you delete this? Okay. So this is the question, right? It is 1 over, what is it? 1 plus square root of 2 plus square root of 3. Right? So
yes.
first, I will do like this. Let me just use different color. This red is really I will multiply both by this. 1 plus square root of 2 minus square root of 3. And what do we have here? Here we have 1 plus square root of 2 plus square root of 3. And here we have 1 plus square root of 2 minus square root of 3. Okay? Here, if you just take this one, a plus b. A minus b. Okay? So now, let's simplify this. So in the numerator, we have 1 plus square root of 2 minus square root of 3. So in the new denominator, what we have here? Here we have 1 plus square root of 2 squared minus square root of 3 squared, which is equal to 1 plus square root of 2 minus square root of 3 over what we have here. 1 plus 2, that is 3, plus 2 times square root of 2. This part,
Teacher,
right? If you
what
expand this. How about this one? It is minus 3. So now 3 is gone. Again, I multiply numerator and denominator by square root of 2. Okay, now what we have here? Here we have square root of 2. Square root of 2 times square root of 2, that is 2. Minus, here we have square root of 6. Over, what we have here? Here we have 4. Now use your calculator, evaluate this, and also evaluate this. You'll get the same answer, but your answer is very different.
One second. Root. Root of.
Okay.
1 second, I'm checking with the calculator.
Yeah, check it, please. Let me just have a look at something.
Can I say how I did?
Again?
What? Can this be correct? 1 plus 1.
No. Anat, how are you writing like this?
Like compress the fraction. I mean, take the
1
fraction.
plus, let's say 4. Is it equal to 1 over 2 plus 2? Is it equal to 1 over 2 plus 1 over 2?
No.
No. So you're like, how can you write like this? 1 over a plus b is not equal to 1 over a plus 1 over b.
Okay.
Okay?
Okay.
Another question, one more question I have for you, and after that, maybe we'll finish this. Another similar question. How about this one? 2 minus square root of 2 minus square root of 3 over, and here we have 2 plus square root of 2 minus square root of 3. Can you rationalize its denominator now?
Yes.
4 minutes. Do it on in the paper.
Teacher, can the numerator be like so long?
Yeah, of course. It can be anything. Here we need to make the denominator a rational number. Numerator
What?
can be anything.
Should I simplify as much as possible?
So did you get anything? Did you get the answer? Or...
I got the answer, but not simplified. Actually, I got the answer. No, I got the answer.
Okay, what is it? Tell me.
Denominator is 23. Numerator is minus 3 plus 4 root of 2 minus 3 plus 4 root of 2 minus 3 root of 6 plus 8 root of 3.
8 root of?
3.
That's all?
Yes.
Okay, if you simplify this, here we have 3. Okay, I think we cannot simplify this.
Okay.
Let me check the answer. Yeah, actually it should be all plus. Why you got minus here?
What?
I have plus 4 times square root of 2, 6. I got different answer. Okay, let's just keep this. Alright, look, here we have. Okay, here we have 2 minus square root of 2 minus square root of 3 over. Here we have 2 plus square root of 2 minus square root of 3, right? First, here we have something minus something. So I multiply by it is plus. I mean conjugate. 2 minus, I'm going to write this one as square root of 2 plus square root of 3. And here we have, if you multiply it's plus, here we have 2 plus square root of 2 plus square root of 3. Over what we have here. Here we have 2 plus square root of 2 squared minus square root of 3 squared. Is your first step the same like this?
Actually, the numerator is different. It's 2 2 plus root of 2 minus root of 3.
So you group differently, right? You group like this, maybe 2 and these two things.
No, I grouped this one. 1 second, I draw.
How did you group?
2 plus root of 2 as 1 plus.
Yeah, we did the same thing then. Here also, I did the same thing.
But here the signs.
No, this is this one. This one. We already have this right here.
Ah, sorry. Sorry.
This is second one.
Okay, I have the same.
Okay, now if you expand this, as you see here, we have something minus something. Here we have something plus something. So that's equal to 2 squared minus square root of 2 plus square root of 3 squared over, yes. How about here? It is 4 plus 2, that is 6, minus 4 times square root of 2. Minus, here we have 3, which is equal to, so here we have 4, minus, if 2 plus 3, it is 5, minus 2 times square root of 6, over, how about here? We have 3 minus 4 square root of 2. Right? So now immediately 4 minus 5 is negative 1. I multiply numerator and denominator by negative 1. What happens here? Then we have this one, 2 square root of 6 plus 1 over 4 square root of 2 minus 3. I just multiply numerator and denominator by 1. Also without this, you can do this, but I just don't want to get confused. Now, here, if you multiply numerator and denominator by 2 square root of 6 plus 1, 4 square root of 2 plus 3. So here we have 4 square root of 2 squared minus 3 squared.
Teacher, why you have plus 3?
No, because this one is minus, right?
Yes, I multiplied by minus that. I multiplied by
minus. If we have a minus b, I should multiply this by a plus b, right?
Yes.
So that's why here we have 4 square root of 2 plus 3.
Yes.
So here we have 2 square root of 6 times 4 square root of 2. That is 8 square root of 12. Plus 3 times 2, it is 6 square root of 6. 1 times 4 square root of 2, that is 4 square root of 2. And here we have 3 over, and this one is 8, 16, 32 minus 9, that is 23. Or the last step, because this 12 is 4 times 3, I can write it as 16 times square root of 3 plus 6 times square root of 6 plus 4 times square root of 2 plus 3 over 23. Now check the answer. Calculate this one and calculate this one. You get the same thing.
Teacher, but in here, like I didn't multiply like 1 second. I'm sorry, why did this happen? Teacher, I didn't multiply this equation by minus 1, and like I used the same, but I don't know why I got 3 plus 4 root of.
Yeah, actually, look, what I'm trying to say here is, even if you don't multiply, we will get the same answer. But usually, why did I multiply? If you don't multiply, here, what we have here? What we have here? Here we have like this, right? Negative 1 minus 2 square root of 6, right? Over 3 minus 4 square root of 2. And we have, when we had minus minus, actually we get more confused more. That's why we just try to keep everything plus. And that's why if I multiply numerator and denominator by negative 1, nothing changed here. Because of this minus, I think you made a mistake.
No, teacher, no, I found my mistake. My mistake is here because I wrote 6 plus 4 root of 2 in here.
Yeah, why did you write plus?
So because this one is plus as well. This one is me, it should be plus.
Okay, okay, I got it, Ibrahim. Okay. Okay, why did I why did I write minus there? Okay, just a minute. So we multiply this. Okay, here it is 3. It is 4 plus 2, it is 6. Okay, it should be plus. It is plus. So at the time, this should be plus, right?
Yes. And that one should be minus as well.
Oh. Maybe, Ibrahim, your answer is correct, maybe. Okay, let's continue like this. Maybe you'll get the same answer now.
Erase it.
Okay. Uh, okay. So now here we have, I can just keep this minus. Then here we have minus 1 plus 2 square root of 6, right? We should multiply by this minus. So here, let me just write like this. 4 square root of 2 minus 3. So here we have then 4 square root of 2 squared minus 3 squared, right? So that's equal to, I just keep minus here. Then 1 times 4, so here we have 4 square root of 2. 1 times negative 3 minus 3, 2. So here we have 8 plus 8 square root of 12. And here we have minus 6 square root of 6
Teacher, but why
over,
we did
here we
that?
have 23, which is equal to, if you multiply by minus, so here we have 3 plus, here we have plus 6 square root of 6. Here we have minus 4 square root of 2. Here we have minus 16 square root of 3 over 13, 23. Is it your answer? Minus,
Not uh, why we didn't multiply both sides by this number? 3 minus 4 root of 2 instead of this one.
yeah, because this one is a plus b, right, Ibrahim? In the numerator, we have a plus b. So actually, you multiply by this thing, or you multiply by, for example, okay, if you multiply also this one, we should get the same answer. Look, here we have, okay, let me just do like this. Here we have minus 1, minus
Nothing.
2 square root of 6. Huh?
Actually, I had because I forgot the minus in the denominator, so the answers will be the same. Nothing.
If you multiply by this, what we have here? 3 squared minus 32, right?
No, my
Is it?
problem was that I forgot the minus because 9 minus 32 was minus 20. I wrote 20 only.
Okay, minus 3, 8.
But because of that minus, everything changed.
Okay, is this correct, Ibrahim? Did you see your mistake or?
Yes, my mistake. I forgot it minus before 23.
Okay.
I should here had minus. I should delete it.
No, but
No, I mean if I put minus, that will become minus 3 minus 6 root of 6 plus every things on the top will have changed.
okay. Okay. How about this question? How would you do that, Ibrahim? Let me just ask one more question. Then after that, we'll see. The same question, you have to rationalize a minus 1 over square root of a minus cube root of a.
Should I
Can you
do?
rationalize its denominator? I just want to see your method. How would you do this question? You can do in the paper, or
should it be multiplied each side by root of 2 plus cubic root of a? I mean,
okay. Let me write again. Here we have a minus 1 over square root of a minus cube root of a. Maybe if you try, you can do this, Ibrahim. In this kind of roots, let me just suggest you one method.
we
How I would do this one is, we have a cube root and square root of a, right? Let me just use new variable here. Let me just introduce here. Let's say 6 root of a is equal to t. Okay. At that time, what will be this a? A will be equal to t to the power of 6, right?
Yes.
So now if we substitute here using this, then we will have here, t to the power of 6 minus 1 over, how about the squared? It will be
t to the
t
power of
cubed.
3.
How about this one? It will be t squared. Okay, so now I can simplify this. This one is, as you see here, I can write it as t cubed squared minus 1. And here we have t squared is a common factor, right? T minus 1. So that's equal to, what is this? It is t cubed minus 1 and t cubed plus 1 over, and here we have t squared times t minus 1. I mean, dealing with just exponents is much easier than surds, right? And the first one is equal to t minus 1, t squared plus t plus 1. And here we have t cubed plus 1 over, here we have t squared times t minus 1. So these two things are gone, right? And we know that I need to write this as t to the power of 6, because we know that t to the power of 6 is equal to 8. We have to rationalize the denominator, right? So if you multiply numerator and denominator by t to the power of 4, what do we have here? T to the power of 4. And here we have t squared plus t plus 1. And here we have t cubed plus 1. And here we have, what is it? It is t to the power of 6. Okay, now I can substitute here. What's the denominator? It is a t to the power 4. That is, what is it? T to the power 4 is
of 4 is my cubic root of a squared.
It is cubic root of a squared, right?
Yes.
And here we have t squared. That
Cubic root
is
of a
4th root of a plus t, 6 root of a plus 1, and t cubed, that is square root of a plus 1.
Why 4's cube? I mean, in here, why we have 4's root? It shouldn't be 3.
T squared, what is t squared?
T squared we said here, it's a to the power of 3. A cubic root.
It should be cube, right?
Yes.
Okay. Okay, it should be cube. Okay, this is just a method, because when we have too many this kind of roots, one powerful method is you need to introduce some kind of variable like this, so that we will not have any surd, any radical in the expression. And dealing with exponents is much easier. After you simplify this, and after that we have to resubstitute the what is it? That's variable again. Okay.
Okay.
All right. All right, Ibrahim, let's finish this. We will just practice a few more questions, and I will finish indices for today. Now we have maybe a few minutes, Can we continue like 5 more minutes? Do you have time or are you
Yeah.
tired?
No, I have my time is until night is free.
Okay. Just a few questions because I want to finish this chapter today. Ibrahim, after that, maybe next time we have
Alright.
one more chapter, linear inequalities. After that, I'm going to give you 3 tests, okay? And one,
Teacher,
two, 3 tests.
alright.
Okay, you should do them and submit this. Okay, Ibrahim, we are going to do these questions together. I think you have already done these questions, right?
Yes, but my name is Arad.
Arat. Why? I confused with Ibrahim. Okay, Arat. Your name is Arat. Okay, good. So we have to simplify these questions. Just Ibrahim, let's solve Arat. Arat, I'm sorry, Ibrahim. I don't know why am I pronouncing Ibrahim. Arat, tell me what are this, and let's simplify quickly. Okay, let's try to do this for speed. Okay, not for knowledge. Okay, what is it?
21 plus 21 minus
No.
4.
What is this? Just tell me step by step.
Step by step. Minus 4 plus 25 and minus 25 plus 8.
Okay, good.
Minus
They are
4
gone. So that's
minus 4.
4, right? And how
Uh,
about this?
that one 8 times
Minus 8, right?
what?
Negative 8.
Minus 6. Minus 8 times, actually, we should put that one in the denominator. It become minus 8 only.
Okay, so it is minus 1 over 9, right? Which is equal to
Answer is 8.
8. Good. I will skip this. How about A here?
It's 5, 6 over 5.
1
6
over
over,
2 first, 1 over 3, right?
yes.
Plus 4 over 5. Let's do step by step. This one is 6 over 5, so it is 6 over 5 plus 4 over 5 to the
The answer
power of negative 2. So that's equal to 2. So
2.20.
that's equal to 1 over 4. Okay, how did you do this question?
Which one? And this one, 10 equal is meant 2 to the power of 8 times 5 to the power of 8 in the bracket minus 2 to the power of 6 multiplied by. Can I
If you
write?
do like this, it will be much easier, Ibrahim. What is a common factor here? 10 to the power of 6, right? So here we
All
have
right.
10 squared minus 1. How about
Okay.
here? 5 to the power of 6 is common factor. 5 squared minus 1. And which is equal to, exponents are the same, so we can write it as 10 over 5 to the power of 6. And this one is 99 over 24, which is equal to 2 to the power of 6, right? So here we have 2 to the power of 6, that is 64. 64 times 99 over 24.
Then you
If you
simplify.
divide by 8, here we have 8, divide by 3, 33. That's equal to 264.
Yes.
Oh, you did this differently.
No, actually, I did like this. I forgot it. Now I check my note. It was the same way.
Yeah, I think this method is much faster and easier. Because if you just write this 10 as 2 times 5, it will be more confusing.
Yes.
Okay.
Okay.
How about this question?
That one, was it in the test? Oh,
Yeah, I think so.
this one you should make common out. No, actually you can. You can make common out. Common out is a squared in the top.
Yeah, here we have a to the power of n times a squared, right? Minus a squared times a to the power of minus n.
Then you
Oh,
take out.
did you do it like this?
Uh, then I took out it. Yeah.
Yeah, here we have a squared over a cube. Inside the bracket, the same, right? They cancel out each other. So that's equal to 1 over a.
Yes.
Good. How about this question?
This question, actually, you should comment out the second, third, and fourth one with the 3 over 4. Actually, first you simplify 2 and 4. It will become 2 at the
No, no, no.
bottom.
How about, as see here, Ibrahim, 3 to the power of x minus 1, right?
Yes.
So if you just take this 3 to the power of x minus 1 out, what is left here? 2 times 3 to the power of, what is it? Square,
Mm.
right? Because minus
Are we
2
doing
plus
the
2 is
top?
1. Plus here we have 1 minus 3 to the power of, here we have 2 minus 1. So here we should have 3. Over, here we have 4 times 3 to the power of x minus 1. So now we can cancel them, right?
Yes.
That's equal to 2 times 9. It is 18. 18 plus 1, 19 minus 27 over 4, which is equal to minus 2.
Only a minus.
Okay,
Yes.
good. Okay, I will
A was
skip. This is a similar question that you asked, Ibrahim. Also, actually, you need to write the left-hand side as powers of 2 and 3. And 2 and 3, these are, what is it? Prime numbers, and also a and b are integers, so they must be equal to each other. From here, what we have here, 2 cubed times the 6 is 2 to the power of 4, and the 3 to the power of 4 over this 18 is 2 squared times 9, so it is 3 to the power of 4. That's equal to 2 to the power of 8, 3 to the power of b. These two things cancel each other, right? And also 2, so 2 to the power of 5 is equal to 2 to the power of a times 3 to the power of b. So from here, a must be equal to 5 and b must be equal to 0. So a plus b is equal to 5.
I think it was in the test. Something like. But the hard ones were 17, 24, and the last one. These three were so hard because it was only the unknowns.
Which one? Which test?
The test which I didn't know the number 24. Number 17 and the last one were hard as well. Like number 17, I worked on it for about 3 hours.
Okay. Which one?
17. 17.
17.
Yeah.
This one?
Yes, that I got the answer, but it take a lot of time.
Uh, but did you solve this without using logarithm?
I used logarithms.
Oh, you should do this without logarithm.
Actually, I did 80% of the test with logarithm.
Hmm. Here, a plus b is given, right? Right, Ibrahim? So if a plus b is given, Ibrahim, you see here, if you multiply side by side, what we have here, a times b is equal to 3 to the power of 2b plus 2a, which is 2 times a plus b. And we know a plus b, that's equal to 3. So here we have 3 to the power of 6.
Uh, it mean I waste my time for about 3 hours.
So what is it? 3 to the power of 6 is 729.
Whoa.
Just multiply side by sides.
Actually, I did this, but I forgot you can add.
Uh, because here a plus b is given, that means we need to use it somewhere here in the solution.
First, I did like make it a is equal to 3 minus b, then put it on the equation, then
Oh,
again.
you made it more complicated. As you see here,
Yes,
just multiply side by side. Immediately we get a times b on the left hand side. On the right hand side, if you simplify, we have this one. We know what is a plus b. That's equal to 3. 2 times 3 is 6. So just reach the power of 6. That's the answer.
This means my answer is wrong. Yeah. And the last one, number 32.
Okay.
I got the answer of 15.
How did you get it?
Actually, I forgot it.
Look, Ibrahim, very easy way. Let me just show you here. 9 to the power of x plus 9 to the power of y over this 3 to the power of x plus y times 1, right? Minus 1. I can write it as 3 to the power of 1 times 3 to the power of x plus y, which is equal to, now 3 to the power of negative 1. It goes up. So here we have 3, right? And here we have, I can write it as 3 to the power of 2x over 3 to the power of x plus y. This 3 to the power of x plus y is a common factor, plus 3 to the power of 2y over 3 to the power of x plus y, right? I'm just using this idea. A plus b over c is equal to a over c plus b over c. Now from here, if you simplify, what do we get here? The first one, 2x minus x plus y, that's equal to 3 to the power of x minus y. And how about here, 2y minus x plus y, that is 3 to the power of y minus x. And we know that expression, right? It's given here. It's exactly the same. That's equal to 5. So here we have 3 times 5. That's equal to 15.
Then hopefully my answer is correct.
So 32 is 15.
I don't know why I did all of them in a hard way.
Maybe you have never solved this kind of question before. That's why.
Maybe.
But actually, these
Can
questions, you have
you
to solve them without using logarithm, because this topic is taught before logarithm.
give one more this kind of test?
You finish all of these questions?
Yes.
Okay, if you practice that much, that's enough. If you want, I can give you, but now we have a lot of topics to cover. As you solve more and more questions, now in the exam, I will ask you some different questions. In this way, we can improve, because if you spend too much time on this, we may not have enough time to cover topics, because we have a lot of topics to cover.
No, because I have a lot of free time, and this one I like doing like this, expressing. So I said like,
Okay, I'll try to send you. Okay,
thank you.
all right. How about the second test? Also, did you finish the surds?
No,
Okay, also have a look at those questions. Okay.
because Surds will always hold. Surds will always hold hard.
Okay.
I mean hard like like root of 3. It looks strange, like a root.
Okay. So Ibrahim, now next time we will talk about linear inequalities. Okay.
Yes.
And I think you know how to solve linear inequalities. The questions I will send you now, also have a look. Also, I will send you one test, the first test. Test Ibrahim, do you have printer?
Yes.
So you have to
Meaning
print out the paper, write on it, and using camera scanner, you have to scan it well, nicely. Okay.
I searched for it, I didn't find it.
Really?
Can you send a link? I searched cam scan, but a lot of things came, but none of them has this name.
You use Android?
Yes,
Okay, show me. Did you just type this one? Look.
it's this one. Yeah.
No, the first one. You see the first one, CS? The first one at the top. CS.
Yes. It doesn't. CS.
Yeah, that one.
Okay.
Ibrahim, that app is very good app. You can sign in with your Google account or something. Okay, even without telephone, anywhere, if you have PC, you can access and all your documents will be there. So also you just try when you take the picture, if you do the questions on A4 size paper, when you just scan this, it scans and adjusts, make adjustment very quickly. And the quality is really good. You can save it as PDF or JPEG or any different format. And also sharing is very easy. You can email to me or share with WhatsApp. Okay. First have a look. Okay, try this. You will like this. Very, very useful app. So using this one, you have to send your solutions to me. Okay.
Solutions?
Yeah, I mean, I'll send you one test now. So you have to solve it. And in a given time, you have 90 minutes to solve the questions and send it to me. You are not allowed to use calculator or anything.
No, okay. And just my solutions I'm writing in another page, in another paper,
No, no,
and
no.
I
You
don't.
need to write everything in the exam paper. You should print it out. You have enough space after each question. You have to solve it there.
No. Just should the solution be clean? Because I never put clean.
Yeah,
I
you will get
always.
used to it. Yeah, usually in international exams, it's like this. The question, after that, there's enough space. You have to do all your work there.
Mm. And should the like examiner understand the solution?
Look, Ibrahim, let me show you. Now you can see my screen, right?
Yes.
Let me just show you one example. Here, L1, for example.
And
Okay.
this is the same Olympiad as the, like, how many type of Olympiad do we have?
No, no, no. The Olympiad questions, I will just keep asking you maybe 2, 3, 4 questions. Okay. Now,
Oh,
these are about chapter 1, 2, 3. It's about quadratic equation and the indices, and after that, linear inequalities.
okay.
And also, there are some challenging questions. Okay.
Mm.
So, this is the test, the cover page. So this is the date, due dates. You have to submit before this. All the rules are written. Next page, for example, this is for grade 7. So what is the sum of 4x dollars and 4x cents? Express your answer in cents. So you have to write your answer here. Like, let me just show you, Ibrahim, here. Okay, just give me a minute. Ibrahim, do
Teacher?
you ever use this Microsoft Edge?
Microsoft. And the thing,
If
but
you open with
yeah, I use,
Microsoft
but
Edge, you
I
can
can,
write on it. Look, I'll
I know,
choose the pencil, for example, any color. Which one? For example, this one. Okay. And
I
then I
use a
can
lot.
do this. You are doing this question for after you print out, Ibrahim, you need to write, okay, solution. Your solution is 4x dollars plus 4x cents, which is equal to 400 x plus 4x cents, which is equal to 404 x cents. So your answer is dot, dot, dot. It is 404 x cents. You should do something like that. You show your solution here.
On it means I cannot like write my solution in a strange way, like everything like messy.
No, no, if you just write like this, you will get used to it. Because in the exam, usually, Ibrahim, you have some space. You must show all your work there, not on separate paper.
Teacher, but usually it take a lot of time.
Why it takes a lot of time? Why?
Because always I write in like this one.
Okay, but when you print out, the questions are there. Just you have to solve it. That's it. It doesn't
I
take
know.
much time. Okay.
Okay.
Ibrahim, try it first, print it out, solve this, and scan with that app. Send it to me. Okay. And again, I will discuss about this.
Okay.
Okay.
And should I send the answers to you? The answers for this test?
Answers to what?
For this test, which you gave, which I have now questions from it.
Yeah, do you use email?
Can it be WhatsApp? Because usually my email usually doesn't work. It will
Okay,
like
then
some.
send it to my WhatsApp then. Okay.
Okay.
Okay. Okay, Ibrahim, then that's clear. I will also send chapter 3. Ibrahim, your math is good. Also, actually, in the same way, you need to solve more different questions to also improve your vocabulary, also English. If too easy, you can skip, but try to solve as many questions as possible. Okay,
Okay.
good. Okay, Ibrahim, then that much is enough for today. I will see you on Tuesday, right? Next Tuesday. Now I will send you test 1, and after that, chapter 3 questions, linear inequalities.
Is this a linear equality? Like what type? Is it like y equals
Yeah,
x
it's
more
like
than?
3x, for example, plus 5 is greater than or equal to 1 over 2x plus 3, for example. Linear
Oh,
inequality means here we have linear expression that is greater than or equal to 0. We call this linear inequality.
okay.
And how do you solve this? Similar to linear equation. The only way is when you divide or multiply both sides by negative number, we have to change this inequality sign, right? Ibrahim, have a
Uh,
look, okay? If you have no idea, no problem. If you can solve it, next time we will talk about linear inequalities, okay?
okay.
Okay. Okay, Ibrahim, if you have any questions anytime, you can write to me in WhatsApp. I will meet you next Tuesday. Okay?
Okay.
Okay. Bye-bye, Ibrahim. See you. Take care.
Bye.
Bye-bye.